let's talk about Cisco ACI. It's an incredible, policy-driven fabric for sure. But here's the thing. What happens when your shiny new data center needs to talk to, well, the world you already have? That's what we're digging into today, that core challenge of integrating your ACI fabric with your existing Layer 2 networks.
Okay, so picture this. Your ACI fabric is humming along. You've got your spines and leaves all deployed, policies are looking good, but you're not done, right? Of course not, because you've still got physical servers, those trusty old legacy switches, and a bunch of critical VLANs that you just can't move over in one shot. So the big question is, how do you bridge that gap? How do you get these two worlds to talk to each other like they've known each other for years?
And this diagram really lays it all out. Up top, you've got the ACI fabric doing its thing, managing workloads. And down below, that's your traditional network with its own set of endpoints. What we're trying to do here is take a broadcast domain, see the one for the web EPG, and stretch it from inside the fabric all the way to the outside world. The goal is to make it seem like they're all just plugged into the same good old-fashioned switch.
So, how are we going to solve this puzzle? Well, we've got a pretty clear roadmap. First, we'll introduce the two main ways you can do this Layer 2 extension. Then we're going to dive deep into each one. We'll start with EPG extension, and then we'll get into bridge domain extension. After that, we'll put them head-to-head to see which one's right for you, and we'll finish up with something you absolutely cannot ignore, loop prevention. Super critical in this kind of hybrid setup.
Okay, let's get into the nitty-gritty of L2 extension. When you find yourself needing to stretch a broadcast domain outside of that ACI fabric, you've basically got two really powerful, but also really different ways to pull it off. Let's take a look at what they are.
So, method number one is all about extending an endpoint group, or an EPG. Think of this as the direct route. You're basically just stretching an existing security group out to a physical port. Pretty straightforward. Method number two, though, is a bit more formal. It uses a special, dedicated object called an L2 out. This doesn't just stretch an EPG, it extends the entire bridge domain, and that creates a really clean boundary. So let's start by breaking down that first one.
All right, first up, EPG extension. You'll hear this one talked about a lot because it's often seen as the simpler, more direct path to getting things connected. And, the name kind of gives it away. It's all about the endpoint group.
So, what does this actually look like in practice? Well, you take a regular EPG you've already got, let's say it's for your web servers. Then you go in and create what's called a static path binding. This binding is you telling ACI, hey, map this EPG and its VLAN to this specific physical port on this leaf switch, the one that's plugged into your old network. As far as ACI is concerned, that whole external network is just another place where endpoints for that same EPG happen to be hanging out.
And here you can see it in action. The web EPG for VLAN 10, it's right there on a VM connected directly to an ACI leaf. But thanks to this EPG extension magic, it also exists on those VMs connected way over on the legacy switches. They are all, and this is the key part of the same EPG. They're sharing the exact same policy, even though they're in completely different parts of the network, physically speaking.
Okay, so what are the pros and cons here? Well, this method is absolutely fantastic for migrations. Seriously, you can just move your web servers into ACI one at a time, and they all stay neatly in the same security group. But, and this is a big but, spanning tree. You have to be careful, because you've stretched one big broadcast domain, a topology change, a TCN, out on your external network can actually trigger MAC address flushes for your endpoints inside the ACI fabric. That can mean a little blip of traffic disruption, so it's definitely something you got to plan for.
All right, now let's switch gears and look at method number two. This one builds a much more structured, more permanent separation. We're talking about extending the bridge domain itself using a thing ACI calls an L2 out.
Now, with this approach, you're not just stretching an EPG that's already there. No. Instead, you create a brand new special purpose EPG. You can think of it like a gatekeeper. It represents that entire external L2 segment. And what this does is it keeps the outside world logically separate from your internal application EPGs, even though, under the hood, they're all sharing the same broadcast domain.
And here's what that architecture looks like. See inside the bridge domain? You've got your normal internal app and web EPGs. But now you've also got this new thing, a Layer 2 external EPG. They all live in the same bridge domain, which means, yeah, they can all talk to each other at Layer 2. But, and this is the crucial part, they are totally separate points for enforcing policy. That separation, that's the key benefit you get with this method. Okay, before you jump in and try to configure this, it is super important to get your head around the ACI policy model that makes this all work. It's a top-down thing. You start by defining your L2 out. That's what creates the external EPG. Then you link that L2 out to something called an external bridge domain. That's where you define how you're connecting to the outside. And that domain points to an attachable entity profile, or AEP, and that's the final piece of the puzzle that ties all this policy down to the actual physical interfaces on your leaf switches.
So when you're actually in the ACI Peak GUI clicking around, this is what it looks like. You can see the key things you have to fill in. You give it a name, you tie it to that external bridge domain we just talked about, and then, this is the big one, you tell it which internal bridge domain you want to extend. After that, it's just a matter of specifying the path out and the exact 802.1q VLAN tag you want to use on that link.
Now, once that L2 out object is built and the external EPG is created, you basically just treat it like any other EPG you've ever made. And this is really where the power of ACI shines. You can see right here, we're on the policy page for that external EPG, and we've applied a web services contract. That contract is what's going to explicitly allow traffic to flow between our internal web EPG and all those devices sitting on the external network.
All right, so we've looked at both methods in pretty good detail now, EPG extension and the bridge domain extension with an L2 out. So let's put them head to head. It's time to figure out which one is the right tool for your specific job.
Let's break down the real differences here. The big one is the EPG structure. With EPG extension, everybody, internal and external devices, they all share one big EPG. But with bridge domain extension, the external network gets its own, dedicated EPG. This really means EPG extension is perfect for those temporary migration projects. But the BD extension, with its super clean policy separation and the fact that it's immune to external spanning tree events, that's built for permanent, rock-solid, secure connections. And this side-by-side really nails the difference visually. Look on the left, that's EPG extension. You've got one single wide EPG that stretches across both the internal VM and the external network, all on VLAN 10. Now look at the right, that's BD extension. See how you have two totally distinct EPGs? They're living inside the same bridge domain, sure, but they are separate. This is the core architectural choice you have to make.
Okay, time for a really critical operational topic. Anytime, and I mean anytime, you connect two layer 2 domains, what's the first thing that pops into a network engineer's head? Loops, right? So, since we're plugging our fancy fabric into an external layer 2 network, you better believe we need to talk about loop prevention and, of course, spanning tree.
Now, if you take away only one thing from this section, let it be this. The ACI fabric itself does not run spanning tree. It just doesn't. It's got its own cool ways to prevent loops internally. But it's also smart enough to know that the rest of the world does rely on spanning tree, so it actually helps it along.
Let's actually trace the path of a packet here to see how this works. So, the external spanning tree root switch sends out a BPDU, right? It hits the first ACI leaf. That leaf takes the BPDU, wraps it up in VXLAN, and floods it across the fabric. But here's the clever part. It only sends it to other leaf ports that are in the same access VLAN. So when the second leaf gets it, it unwraps the packet and sends the original BPDU back out. Now that external switch on the right sees the same BPDU come in on a different port. It goes, aha, a loop, and it does its job and blocks one of its own ports. Pretty cool, right?
So the big takeaway here is that this BPDU flooding thing is totally automatic. You don't have to configure anything to turn it on, it just works. It's also very specific to each VLAN, which is so important. BPDUs from VLAN 10 are only ever going to be flooded to other ports in VLAN 10. That makes sure you don't get your different spanning tree domains all tangled up. And of course, you still have all your classic tools like BPDU guard and filter if you need to lock things down on a port.
But ACI isn't just sitting back and letting STP do all the work. Oh no, it has its own very powerful loop detection protocols. For instance, it uses LLDP to catch fabric miscabling. You know, like if someone accidentally plugs one leaf switch into another. And then it's got something called miscabling protocol, or MCP, to find loops that happen downstream from the fabric, even if they're hidden behind a firewall that's eating BPDUs. So you've got this extra layer of protection that works right alongside the external spanning tree. So we've covered the what and the how of stretching layer 2 domains out of your ACI fabric. We've compared the two big methods, we've talked about loop prevention, and all of that leaves us with one last, really critical design question you have to think about. Knowing that ACI just floods BPDUs and doesn't actually play the spanning tree game itself, where you decide to place your spanning tree root bridge in that external network, well, that becomes one of the single most important architectural decisions you are going to make.